They won't hear you say because the mic is muted. I think YouTube.
Yeah, I'm going to check it out. You said that if you so
Yes, I don't think that it's B. because the prepositions they're going in opposite directions. So it's first going to be all of them is going to be equal to 0, wouldn't it be? If they equal each other, they're going in opposite directions. So wouldn't it? So I'm thinking the answer is E. I'm not 100% sure.
So I think I was saying I think it's B, sir.
I think B is correct.
Please do me a favor, those of you on YouTube. I have tried my last option. I'm putting it on. Basically, I'm switching on every device I have next to me. Can you hear me? Let me bring. Oh, you can't see though. YouTube, please update me if you can hear me. Okay, the other ones, let's go back. Teams, I'm recording this one. If everything goes wrong, anyways, we're gonna upload the Teams recording onto the YouTube. Don't worry, guys. Come on. Caesar, are you back with us? Are you agreeing that B is the correct answer? Lusanda?
Not 100% sure. I'm not 100% sure if it's E, so I'm just thinking that it's E because since they
The
it
forces
wouldn't
are
be
equal and the opposite. You agree that one?
yeah the forces are equal and the forces are equal. Can you please show us in the form of on the way in a superposition form
It's not.
if you
We are
can?
not yet in superposition. This is basically between two charges. One of the charge will attract or repel, but the magnet with which one of the charge attract or repel the other one is always equal in magnitude but opposite in direction.
Okay.
Let me
Now I see.
convince you here. Come back to my display if you see there. You see if they are positive or negative for that data, it doesn't matter. The force between them is Ky of Q and Q2 over R squared. That magnitude is the same whether you are standing there or you standing here. You push each other or pull each other exactly the same way because you are locked electrostatically. However, the rate at which you're pushing that way is the same as to the rate at which this guy is pushing you back or pulling you back for that matter. It is equal but opposite. I'm pushing you that B should be the correct. It shouldn't be E rather.
Oh, okay. Now I understand, sir. I saw
No, it's good.
I saw the formula. Then after that, you mentioned it because I think the question said 2 coulombs, but since the formulas are the same, it's going to be equal, but the direction is going to be different.
Exactly.
So B.
Thank you. B, you come back to us. Great. Everybody saying all the B is all right. Let's go check. Hey. Yes, B is correct. I set it up. Don't worry if it is correct or no. Question number 6. We're almost about to finish here and going into the tough ones. Each of the two small non-conducting, as you read on, also keep an eye. If it is conducting, then it's conducting, it has got a meaning. Each of the two small non-conducting spheres are charged positively, and the combined charge being, okay, I'm going to bring my tablet also on the side so that I could write on. I need to clean this one. Just hold on. I'll clean as you see. Good. Now I need a pen, and then I'm going to make it a little bit so that we can read together. It says, each of two small non-conducting spheres is charged positively, the combined charges being 4. There are 2, okay? One sphere, I'm just going to, hopefully they are touching. Non-conducting is charged positively, the combined charge is, there is a charge 1 Q1 and then the charge Q2, but it says Q1 plus Q2 must be equals to 40 microcoulomb. Agree? When the two spheres are 50 centimeters apart, they are not touching each other. Oh, sorry. That drawing is wrong. Then we got them. They have got a distance R. They have got a charge Q1. Another one is Q2. The R is the distance is 50 centimeters, which is 0.5 meter. I always change into SI unit quickly. Each sphere is repelled from each other by a force of magnitude O. Okay, the force is given. The force is 2 Newton. Determine the magnitude of the smaller of the two charges. Each charge, non-conducting sphere is charged positively. The combined charge is 40. How are we gonna go around? We know the two charges are add up, and then we're gonna get 40 microcoulomb. The force is 2 Newton. The distance is given. How are we gonna go? I don't remember. How do I draw? Can we go like this? F equals to Ky of Q1, Q2 over R squared. But I'm thinking in my head. I don't have any strategy yet. I know that Q1 must be 40 microcoulomb minus Q2. But if I substitute here, Ky's of Q1 into instead Q2 into 40 microcoulomb minus Q2 must be over R squared. I believe so. I'm gonna bring this one a bit in now. You can't see what I'm writing. Do you think this is the best way to go around? What else do you say? Then we know now. I believe this is okay. 2 Newton, there is 2 here. 2, my tablet is sleepy. 2 must be equals to, K is 9 times 10 raised to 9 in SI unit. I'm going to call it Q2 into 40 times 10 raised to minus 6 micro minus Q2 must be over 0.5 square. Must give me Q2. You agree, guys? Is it a better way to go around?
Yes.
Yeah, thank you. Thank you, all of you. Let's go then. Let's help each other. Again, my stuff is not clean. Come on. Okay, then I will say 2 times 0.5 square is 0.25, isn't it? 0.25. Is that true? 0.5 times 0.5 is, yeah. Okay, I'm gonna bring Excel in so that they don't struggle with number. Okay, I'm setting up my side. Don't worry, I'm gonna just keep 0.5 square so that I'm gonna use this one. If I distribute that one, what I mean that one is it's writing now. It's a problem of writing. Q 9 times 10 raised to minus 6 minus 5 go disappear. 9 times 40. 9 times 40 Q2 times 10 raised to 3. I believe that is the case because 10 raised to 9 is there, 10 raised to minus 6 is there. That cancel out. 9 times 40 times Q2 minus, what is that, 9 times 10 raised to 9 q2 square. Q2 square is this one. It's gonna be quadratic equation. Yeah, this is therefore, let me put my Excel and then you will see this equals 2 times 0.5 square. That is, hey, 2 times 0.5 square is 0.5. Hey, is that true? Yeah, I forgot, guys, this multiplication long time ago. 0.5 is equals to, and the other one is equals 9 times 40, which I get 360. You can't see what I'm writing. Times 10 raised to 3 q2. This equals to minus q2 times 9 times 10 raised to 9. Oh, a lot of ups and downs. This should be a way, guys. Solve this one. This is a form of, this is ax squared plus bx plus c equal to 0. We want to write like that, quadratic equation. Then to write in that way, what should I write? I'm gonna take everything, x squared is there, q2 squared is here. No, this is q2 squared, that's 9. Then I will write 9 times 10 raised to 9 q2 square. I'm taking everything here, minus 360,123 q2 plus 0.5 equal to 0. Please solve it for me. I'm not gonna go in. But this, if you think of, it's gonna kill my time though. If you think of the q2 must be minus b. This is minus b. Or, okay, let me give you a formula first. If you remember high school, for such a thing, the solution for this, x is minus b plus or minus the square root of b squared minus 4ac over 2a, if you remember the high school mathematics. In our case, this is a, this is b, and then this is c. Therefore, q2 should be, minus b is positive 36030, plus or minus the square root of b squared means 340 rather. Is it not 40? I believe. I forgot. Check the Excel. The Excel is 3. I've got 3. This is 40, guys. Careful. This is 40. There is 3 here. There is 1 here. It's a messy now. 40, yeah. My b squared, you must square this one. Minus 4 times AC is, A is big. 4 times 9 times 10 raised to 9. C is times 0.5 the whole over 2a. I'm gonna stop here. You check for me. Once I know it's this one, the other ones are messy. I don't know how did it end up long question this one. Is it gonna be like that? Check for me. This is the case. I think that is the best way to go around. Basically, to substitute we use this one. I'm repeating so that you finish the mathematics alone. You know this one. Then I use the q1 for that expression. And then I use the fourth equals to ky's of q1 q2 over r squared. Use that one. Recross it. Go into a quadratic equation. Solve. I'm gonna stop here, man. It's gonna kill my time. Guys, if you say consist, no, continue, I'll continue. Otherwise, are you guys okay? If I leave you. Yeah, good. Lusanda. Okay, guys, this is, it's a first year engineering student, therefore you should be able to solve that ones. This is basically replace, take it out. I don't know which ones it is. You check for yourself. Once you know Q2, solve for Q1. You know Q1 plus Q2 is 40. Just replace. If you get Q2, you get Q1 easily. Go for it. I'm going to leave you here. Rather, let's choose some of the questions here. Hopefully you can still read through the questions. Those displayed here. I don't know. I'm guessing again. I don't think you guys have had the time to look through and then made your head. Did you? Maybe I'm undermining. Do you guys have a nice question to answer here? Which question we start with? Do you have any? I don't believe though, because I sent this morning and then you must have had a class during the whole morning though. And if you are busy, I don't think you would have a time to read. But if you don't have it, I don't blame you. We're gonna just read through, and then if it is simple, I'll just give you a head up, meaning just idea, and then I'll leave you with. Think of the following, for example. I'm also watching on the YouTube, if so, not YouTube. By the way, let me go check my YouTube if there is any. Where is my YouTube? I'm gonna go here. Oh, at least there are people watching. Can hear, yay! Yes, we can hear. Hooray! I'm happy. Thank you guys on the YouTube. Sorry, I kind of abandoned you, and I could see now you guys are there. Happy, thank you. Thank you for the love. Okay, great. Go back to my stuff, my question. Good, they are with us. That's great. Teams, still I don't see comment. Therefore, look, question number 1 says, 2 protons in a molecule are separated by this distance. You have the distance. Find the electric force by 1 proton on the other. I'm not gonna do this. Easy. You know why? The protons, you know the charge of a proton. Don't I have this thing on my tablet? Just hold on. I think I have the question on my tablet. Just hold on. I'm gonna come in. You're watching my screen now. My tablet. Yep. And I believe I saved it somewhere on the document. In the document. Yeah. I only saved the memo. Oh. Okay, just hold on. I could bring the question also. Yep, good. I want to go here. Just hold on for me. I hope I have it here. I'm looking through my... Come on, man, I must have it here. Not there. Yes, I got it. I'm gonna write on it. Rather, you're gonna see the following. Yeah, this is what you're gonna see. This is on my tablet. Yeah, good. I can write on it. See, hopefully nothing is changed. You guys, yes, nothing is changed, and you are still with me. Yeah, good. 2 protons, you see the charge of proton here. You remember that this charge Q is 1.602 times 10 raised to minus 19 coulomb. You have charge. Separated by distance, you have the distance. Therefore, the force is basically the force between 2 protons. You have 1 proton there. You have another proton there. This is P. This is also P. The same charge. The force must be K into Q square over R square. That is the answer. How does the magnitude of this force compare to the magnitude of gravitational force between the 2 protons? Now you need to have the mass. Mass of proton is what is that? Forgot. What is that? Mass of electron is too small. Mass of proton is I don't remember even in my head, but you could go like this. You could see here mass of proton. You could see it is 1.67. Yeah, it came in my mind now. Therefore, the mass is 1.6. Oh, charge, man. That's a charge. Come on. 1.67 times 10 raised to positive negative 27 kg. We did this thing in the class though. Those of FEV, you remember? We did the PHYV rather. We did this thing in kg. Therefore, this is electrostatic force. The gravitational force Fg is, F due to gravity is Gy of m1, which is mass of proton, m square again, over the r square. The problem is with G and F. Please work through. I'm going to leave you. And those of you in FEV or PHYV, there is a memo that you could download now directly. Therefore, you could see here the answer here. That of Fe is this much. Fg, Gy of m1, m2, the mass of proton is there. You could go through CISA.
So I want to know, are you writing something?
Yeah. You can't see. This
I can't see. Nothing is moving, sir. I only see electrical fields, tutorial 1.
Hey, on the Teams.
Now it's moving, sir.
Can you
Maybe
see?
it was lagging or something. Yes.
Maybe there is a lag in between. Basically, what I was talking here is you have the memo. Are you from FEV or PHYV?
PHYV.
Yeah, good. Then you could have access to the memo. Also, you could download this memo directly. Okay. Then question number 1, but therefore easy. I'm not gonna spend time because there might be more questions to come. Okay, about this one, this is also theory, by the way. I will take you through a little bit. Unless you stop me, guys, on question number 1. Do you think you will struggle with? Here is the memo. You have got the electric field force. You have got a gravitational force. We did this one in the class also with the FEV, the PHYV student. Then the ratio between the FEE, the electrostatic and the gravitational force, you could simply see this is the difference. Okay, everything is there for you. You shouldn't struggle with. Number 2, rather, I'm going to this one. It says about Richard Feynman. One said it says if 2 persons stood at arm's length, the distance between them is 1 arm length from each other, and each person had 1 more electron than proton. You see, one of the person is positively charged, the other person is negatively charged. One person has got 1% more electron than the proton. Then the force of repulsion between them would be enough to lift the weight equal to the entire Earth. Carry out an order of magnitude calculation to substantiate this assertion. Again, this is a kind of theory you should go through. I'm gonna just refer you to the thing that I put together here. Here is where, by the way, the question is taken from your textbook, problem number 3. Look, this is a memo, then kind of a guide that I will take you through. You see, the question also need to be understood. There is one person who has got 1% more electron than it is proton. It means he has to be charged. The question didn't imply to you though, what is the number of charge in one individual? Think of yourself. How many electrons are you made of? Other way, what is the total number of electrons in your body? An average person is going to be humongous, tremendous amount of electron, obviously. This is a calculation. If you are a 70 gram, 70 kilogram, kind of, I am 82, I'm too heavy. Then think of you are made of water. In this guy, it is here, even 70 kilogram meter. And then you are made of water. Yeah, basically we assuming now that is order of magnitude calculation. We're assuming, even though we are not all made of water, we have bones, we have different sorts of chemicals in our body. It's not all water, but if you kind of guess 73% of you is made of water, then you could think of this is an okay with terms of calculation. The number of electron or a proton in your body, therefore, with this sort of calculation, remember this thing is Avogadro's number, the 602 times 10 raised to 23, Avogadro's. This is a gram per mole per of that is a kind of molecular weight for water. You go through, you see the gas is you, or if you are young, of course, which is true, less than my weight. If you are around 70, you could think of you are made of 2.3 times 10 raised to 28 electrons, or the same amount of proton. You are not charged. Then it says, if that amount of proton is charged with 1% of extra electron, when excess of 1 proton electron over proton, what means this is the same amount of electron you have, the same amount of proton if you are neutral, add on top of that 1%, which is 0.01, 1 over 100, of the charge of electron, 1.6 is charge of electron, of the total charge that is inside you. This one comes from there. Therefore, 1% extra charged by electron imply that the net charge on you, the extra charge rather, the extra charge is 3.7 times 10 raised to 7 coulomb. Then, now do the force. Force, therefore, Ky of Q1, Q2. Q1 is the, Q2 is the same over here. Put it there. The amount of force you're thinking is 10 raised to 26 Newton. Look how heavy it is. Therefore, this force is too much. The weight of the Earth itself is, this is the mass of the Earth. 6 times 10 raised to 24 is the mass of the Earth. If you multiply by gravity, you get about 10 raised to 26 Newton. Whereas, you see, that is what it says is comparable. I'm going to leave you. This is also kind of, an assumption. Therefore, if it is scratching your head and the thinking that, oh, how did this happen? Go back to the memo, rehearse about it, and then swallow. I'm going to leave you with question number 2 also. I'm going to pass, unless you insist. Because there are tough questions yet to come. Sia, I want you to listen carefully here. Because, you see, this is superposition now. 3-point charges, it says, are located at the corner of an equilateral triangle. Okay, remember, equilateral means the same length as shown. Calculate the resultant electric force on the 7 microcoulomb charge. Is it minus? No, that there is no minus here. Just forget about it. On the 7 microcoulomb charge. We wanted to find what is the net force on this particular guy. I'm just going back to my YouTubers. Hopefully they are all right. Looks like they are not asking question. Good. Are you there? Are you happy where I'm standing? This is therefore it's a superposition. Then the following holds true. What you should be doing, therefore, we are interested on this 7 microcoulomb charge. What you should be doing, therefore, is what is the direction of the force between the 2 microcoulomb positive and then the 7 coulomb positive? Is the force gonna be like this? Those of you on the teams check. Or is it gonna be opposite, like backward? The blue or the red? Sia, you want to come in? Because I want you to pick it up.
It's gonna go to the blue side, sir.
Because they are repulsive. Thank you. Just hold on. I want you to be my springboard. Between the minus 4 microcoulomb, I'm talking about that one. Now the 7, because this, first of all, let me erase that one. This is wrong. Okay, good. This between the negative 4 microcoulomb and the 7 microcoulomb should be along this direction.
Yes.
Lusanda, thank you. Therefore, she is also with us. I'm going to put my xy coordinate there, like here. This is my y coordinate. This will be my x coordinate. This angle is 60, by the way. You know, if it is equilateral triangle, everywhere the angle is 60. If this angle is 60, that angle also must be 60 degree. Let's call this one F4 on 7. And then this one F2 rather. That is wrong. Under. F2 on 7. This one is F4 on 7. Don't worry about the sign. Then I could zoom now and say that the F2 on 7 is that way. It has got an x component. The x component would be F2 on 7 along x would be F2 7 cosine of 60 degree. Then it also has a y component. The y component would be up. I'm going to just bring it here. F2 on 7, y component would be F2 7 sine of 60 degree. I'm decomposing along x and along y. I know what is this angle gonna be? What is this angle gonna be? Somebody help me. We know that angle is 60. This angle is the same as to. Hey, help me. I want to know that angle. What could it be? Think.
Wouldn't it be 60?
Why you say so?
Once-
Yes. Yeah, you're
60.
right. Yeah, you're right.
Because it's the Z, I forgot what it's called. I think it's alternating angles.
Exactly. What he's saying, guys, is if two parallel lines, this parallel line and that parallel line, is crossed by a transverse line, alternate interior angles are congruent. Thank you. You remind me high school kind of. Ole also said 60. Great. This angle is 60, therefore. We agree, all of us. Then the x component of that component again is that way. If 4 on 7 along x is F4 on 7 cosine of 60 degree. It also have the y component. The y component is down. F4 on 7 along y is F4 7 sine 60. We know that one. Then the next is what are the forces? The forces are basically F4 2 on 7 first of all. 2 on 7 is equals to K times 2 microcoulomb times the 7 microcoulomb divided by the distance. What that distance is 0.5 square. What is the other one? 4 on 7 is again the same distance, the same everything is K 4 microcoulomb times the 7 microcoulomb over 0.5 square. Therefore, find the x component, the y component for both, add the x and the x, add the y and the y, then find the resultant force. I'm not gonna go through. Somehow I must have done this one. I don't know if these questions they are not in order though. Oh yeah, it's here. I just wanted for you to be on the right direction. Then the numbers are here. You see, which one I said F1. One of them is F that is K 7 and the 2. 7 and the 2, that is this, the top one, F1 is F7 on 2, is 0.5. I'm gonna write it here, and then I'll show you. Just hold on for me. This one is equals to 503, and then this one is 1.01. What I was doing is, because you can't see, you see this one is known, that one is known, you could put inside here and continue, but I'm not gonna kill. You guys go on. Fx, Fy, the net Fx and Fy is, you could see here, the total Fx is there, The total Fy is here. You see it's negative. The down one is big. That equation is also okay. The net force is 0.872 Newton at an angle of 330 degree. Fy over Fx. This one also, please figure it out. You happy? Can we jump on that one? Great. I could see thumb up some of you. Great. Okay, good. Let's go back to the question. Still we have toughy ones. This one says, question number 4 says somewhere somehow will.
Sorry, sir.
Yeah, Caesar. All right.
If the charge positive, the one that can go back to the
question.
drawing. Yeah, the question.
Or should I come back here?
Yeah. If the positive charge over there, 2 microcoulombs, was maybe positive 4, will the y
The y component become 0.
so they be cancel each other out?
Yes, equal distance, you see, because both of them are 0.5 away from the 7 microcoulomb and they are in opposite direction, then yes.
Okay, so when we calculate the it's similar also when we calculate the electric field also.
Yes, exactly. By then you don't have the 7 microcoulomb there, and then assume you are looking for what is the electric field at the place where that 7 microcoulomb is placed. Yes, you have, exactly. It's only
so
the same.
So the 7 will just be removed and you will just use this.
Yes, you have an open area then, because you cannot define an electric field where the charge is heated.
Oh, okay, thank you.
Good. Go back and what is the question? No, on my tablet. Go up there, and then it says, show that it's a maximum magnitude of Emax of an electric field along an axis of a uniformly charged ring occur at x is equal to this much. This is time taking, but let me give you what it is. Think of the following. You have a charged ring. We did this one in the class. Kind of such a thing. And then it has got a center, it has got a radius r, and then we wanted to find what is, don't have a red pen here. Don't like my pens. Oh, okay, somewhere there. What is the electric field at a point x along the axis? That was the first thing to think of. Show that the maximum magnitude of Emax of the electric field along the x-axis of a uniform charged ring occurs at x is equals to a over root 2 and has a value of this much, it says. The first would be if this thing is charged with a positive charge. You remember about continuous charge distribution, and this thing is all the way charged positively, and then the overall charge becomes capital Q. If you remember in the class, the following is what we did. We said, okay, to first of all calculate, take a portion of this thing on the top and then a portion of this thing on the bottom, exactly symmetric. Find the electric field due to that. This small section now is dl, carries a charge of dq. This one also has got a length of dl. We said ds even in the class, carry charge dq. And then the electric field they produce, if you see the top one will be down, the bottom one will be up, exactly like that way. And then if you call this one is 1, this one is 2, we said this one is DE1 because of the top, this one is DE2. Because they are equidistant, if you remember in the class, we said they're going to cancel each other. We only have the x component of the electric field, DE, which is Ky's of dq over if you say this one r square times cosine of the angle cos theta because of the x component. I'm not going to go to the derivations. Those of you in FVV, Dr. Ethan must have done also the same. But if you do so through the calculations, if you don't mind, just hold on. I'm going to drag it in where we did in the class. This one for those of you with me, just to remind you. Come on, my computer is slow. Yep, it's coming. I'm talking about this one. Hey, and this equation, this solving is somewhere here. We work through this expression, charged ring, and then we said, you see, we just as I talked, the top one, the bottom one, we take 1, 2, they cancel each other. We only have the x component, the cosine of that thing is replaced. Remember theta, cosine is adjacent over hypotenuse. You end up integrating along x-axis, but I'm not going to go there. This is the electric field we have. The electric field along the x-axis at a distance x is kx over a square plus x square raised to 3 over 2 times q. That is where I wanted to start working on. Okay, if you, I'm sure you guys, you know what I'm up to. Then if I take you to the memo, somewhere I must have this one. Here it is. This is the formula to start up. Therefore, for a charged ring, the electric field at a distance x along the axis of the center, along a distance of x is given by that expression. You could see what is on your screen where my cursor is. Now the following is what you should be supposed to be doing. Can you differentiate this? The maximum means dE, that is a trick. When it says a maximum electric field, you should differentiate this one. Differentiation. I heard your mathematics is so behind, guys, in the class also. Let me give you a little bit of head there, or help. Just I'm coming in. Hold. The equation we have is E. I'm writing for me. E equals to K Q x over x squared plus a squared raised to 3 over 2. Now I will show you what I'm writing. I'm going to teach you now mathematics. You see, dE means if you differentiate dE with respect to x, obviously, because the x is which is changing, dx would be differentiating. You see, okay, let me give you another formula. Maybe mathematics supposed to teach you this. If you have the following, f of x over g of x, two function, derivative. If you remember, or if you have gone through, the derivative of this function equals to the derivative of f of x, f derivative of x, times g of x. Oh, let me have a big area. I'm going to restart. We wanted that derivative. Hold on here. This derivative, that the f of x over g of x, both derivative equals to f derivative of x times g of x minus f of x. Now you derive the g derivative of x over g of x square. This is a formula. It's called the chain rule, or coefficient of division chain rule involved. In our case, you could think of it, the f of x is, let me pull a little bit down. F of x is the top one, is x alone. This is constant, remember that thing is constant. I could write, in our case, therefore, dE by dx would be the derivative of k times q times x. Remember, kq is constant. I'm going to write kq. X is differentiated. Therefore, dx by dx is 1. The bottom one is x squared plus a squared raised to 3 over 2 times, this is g of x, minus, you write f of x as it is, k q x, times the derivative of that thing is, now it's a chain rule. You have to remind you, x raised to n. Rosanda?
Can you restart the part with k times q times x squared plus a squared to the power of 3?
Oh, okay. Thank you. You see, I'm going to mathematics, and then I will start for you. Remember, let me first then make it smooth. Let me hold on. Use this formula. F of x is k q x, the one on the top. G of x would be x squared plus a squared raised to 3 over 2. That is a starting point. Then if I have to use this formula, which must be, this is a mathematical formula, then I say, what is f of x derivative? When I derivate f of x, this is constant. I simply say dE by dx, therefore is the top one. If I differentiate kqx, kq is constant, remember? I will keep kq, k times q, and then differentiation of dx by dx is 1. Lusanda, that is what I jumped. Therefore, I don't write this one. Then I forget, leave it. Then multiply by g of x. I'm here. I'm going to be there now. I must multiply. What is the g of x? X squared plus a squared raised to 3 over 2 as it is. I am here now by that sign.
I think I can understand now.
Good, thank you. Minus, now I'm going to write f of x as it is. K, q, x. I must differentiate that function. X squared plus a squared raised to 3 over 2 differentiation. This one is tough again. If it is x raised to n, if you differentiate this thing, it's going to be n x raised to, I'm running out of space. I'm going to come a little bit in, and then I'm going to zoom a bit. What I was talking is, if you are differentiating x raised to n differential, is going to be n x raised to n minus 1. In the same way, what I have is, I must differentiate what is this one, x squared plus a squared raised to 3 over 2 differentiation. That is, let me do it outside, then I'll write it back. That differential, by the way, I'll come back to it. This differential, x squared plus a squared raised to 3 over 2, if you differentiate this one itself, first do the exponent. This equals to 3 over 2 will come out because n is dropping. And then x squared plus a squared raised to 3 over 2 minus 1 is 3 over 2 minus 1. And then the inside one, which is x squared plus a squared differentiation, which I get 2x. That one, therefore, will end up 3 over that 2 will cancel this 2, basically 3x, and then this one is going to be x squared plus a squared raised to 3 over 2 minus 1 is 2, 1 over 2. This is what I left with. What it means is, I'm going to bring it, therefore, I'm going to get a red pen. Remember, I have this one. Therefore, that q of x times, remember the one I get now, 3x times x squared plus a squared raised to 1 over 2. This is 1 over 2. Then I could clean now, if you agree with me. Are you happy there? The mathematics is tough. I don't have option. That is, and then I still having the bottom one, g of x squared. Lusanda, thank you. Therefore, I'm going to clean out the derivative I did here. The whole divided by g of x squared, which is x squared plus a squared raised to 3 over 2 square, because it must be squared there. If you work through this one, which equals to, I'm going to put a bit up, and then kq is everywhere, by the way. If you see that one, kq into, I'm going to make like this, x squared plus a squared raised to 3 over 2. This one never changed. Minus, there is x here, there is 3x squared into x squared plus a squared raised to 1 over 2. Close the bracket, divided by x squared plus a squared raised to 3 over 2 square is going to be cube. I hope you pick it up, the mathematics also. And then if I simplify this one, it's going to be kq is common. By the way, this one is, let me change into blue now. You see, there is 3, this one is 3, I will say into x squared plus a squared raised to, the top is 3 over 2 minus 3, the bottom one, minus 3x squared, x squared plus a squared raised to, oh, I'm running out of space, raised to 1 over 2 minus 3. Then this equals to kq is common into this one. 2 times 3 is going to be 6. 3 minus 6 is going to be 3. It's negative, therefore 1 over x squared plus a squared raised to, what I said, 2 times 3 is 6. 3 minus 6 is negative 3. 3 over 2 minus 3x squared over, this one is 1 over 2 minus 3. That means 1 minus 6 is going to be x squared plus a squared raised to 5 over 2. That is the derivative. This is what is displayed, I believe, on your on the memo. Where? I lost the memo down. Okay. Anyways, you see, yeah, I'm back here. That is what is displayed on the memo. 1 over x squared plus a squared raised to 3 over 2 minus 3x squared over x squared plus a squared raised to 5 over 2. This is exactly what we reached now. This is a derivative of whatever we have there. I'm going to clean the bottom one. See, therefore, mathematics is the best powerful language for this physics, as I said. Okay, go in. Now from that on, it's just basically maximum. What is maximum means? dE by dx must be equal to 0. If you equate this thing to 0, kq will disappear because you cancel the kq because 0 is on the other side. Then basically x squared plus a squared raised to 5 over 2 equals to, take that one to the side, x squared plus a squared raised to 3 over 2 times 3x squared. What it means is, let me come with my tablet, I will show you. If this thing is maximum, therefore kq is going to disappear. As I said, equate this thing to 0, equal to 0, therefore kq disappear, crick cross that one, then I will have x squared plus a squared raised to 5 over 2 must be equals to, take that one to the side, 3x squared into x squared plus a squared raised to 3 over 2. Which one is which one? If I divide everything on both sides, x squared plus a squared raised to 3 over 2, x squared plus a squared raised to 3 over 2. This is not 5 over 2. Yebo, and I'm going to just display. Then that would be basically 3x squared must be equals to, what happened here? X squared plus a squared raised to 5 over 2 minus 3 over 2. What is 5 over, 2 over 2? Oh, equals to x squared plus a squared. Then the exponent disappears. Take this one to the right. 3x squared minus x squared is going to be 2x squared is equals to a squared. Then it's making simple now. You see that nasty mathematics is dying out. Then square, take it, is under square root. 2x must be a, therefore x must be a over root 2. You agree? Are you guys happy? You okay? It's a nasty mathematics, basically, I have to admit. But without it, you can't go. Are you tired, guys? Should I leave you then? Tisa?
So, sir,
Are you there, Tambisa? Tambiso?
I just want to ask,
Yeah, come in.
will the control, can you hear me, sir?
Yeah, it's you. Yeah, I do. Go on.
Yeah, I just want to ask, the time you made this tutorial, it was around 12 and we had a class for next. So I just want to know, will you always do this class this time
It's not only me. We have just hold on. I'll display to you what I am about to say. We have a group of us will be. I don't know what the time is for tomorrow. For example, tomorrow will be enrolled, and it's yes, exactly. We will be having. There was a problem, and I don't know what you guys you could choose. We 2 years ago, last year also, we tried to accommodate student, but there is no good time per se. You know what I mean? And between lunchtime, we kind of had a slot where couple of students can attend. Therefore, based on this one, you see, it's only on Friday that we will be going from 3 to 7 per se, or from 15 to 17. Otherwise, yes, it's going to be on the during lunchtime. However, again, I'm giving you a chance. If you guys come up with something and say that, you know what, it would have been better if this time is moved that way or this way, but difficult to accommodate, I'm telling you, so.
Yes, I understand.
Yeah, therefore, that's where I am. Yeah, and guys, about that so far, this one, basically what I've said for question number 3, know that your electric field is for a ring of radius A is given by that at a distance x along the axis. If you say it's a maximum electric field, basically you differentiate this one and set it to equal to 0. That differential is a mathematical problem. You differentiate f of x over g of x and then know the rule. Then solve for x, and you could see that you got x equal to a over root 2. Once you got a, obviously now, but if there is a force, it says the question asking what will be the force if a charge is placed at that point. Know the E at that particular. Put your x value in this expression. If you now, instead of kqx, you simply say kq a over root 2 times or over a over root 2 plus a squared. That one is also square. If you simplify, you could see that the simplified version of the electric field is this much. If that is the case, if you put a force there, it says you could continue with whatever I have here. Happy. I'm gonna go back to the remaining questions if you guys still have energy. Finished here. Question number 5 is finished, and then question number 5 we did in the class. I'm not gonna go. And those of you in FVV, in case you are here, this is how you go around for question number 5. Think of what it looks like. Electric field lines are emerging from Q2, and then it's pointing toward this Q1. That is one information. Therefore, Q2 is positive, Q1 is negative, because the arrows are toward this Q1 and then away from Q2. 1. 2. The amount of field lines, the number basically, is proportional to the magnitude of the charge. Start from here. 1, 2, 3, 4, 5, 6. If this one is 6, Habitation, welcome back, man. Welcome back from first semester. I remember your name. You came and visited me. We are together again. You said, can we take 5-minute break? By the way, I've got a meeting by 2. I'm gonna leave you otherwise. I don't think I'll come back if I take a break, Habitation. I know I'm also tired though. Okay, proceed. Thank you. Option. Yeah. Therefore, guys, go for question number 5. Q1 must be negative because the field lines are into it. Q2 must be positive. 6. Let's just use it simple. This one is 6. The other one is 1, 2, 3, 4, 5, 6, 7, 8, 9. This one should be 18. 9 times 2. That should be the answer. I think I've got the memo also. All right. Somehow you'll see. Yes. Q1 is and the Q2 is, the ratio is basically negative 1 over 3. That negative Q1 is coming from the negative Q1, which is charge is negative. Therefore, you could easily answer that. It's easy. Should be easy. We did in the class this one. What else could be difficult? A proton accelerates from rest, V naught is 0, and a uniform electric field, which is the electric field is given. At some later time, speed is, V final, and then non-relativistic. Okay, don't take a relativistic into account. because v is much less than the speed of light. Okay, find the acceleration of the proton. Hey, it's easy. Hey, didn't I do this one? Basically, we say force is equals to mass times acceleration, but you remember that in the class we discussed, the force is E, the electric field, times this charge. Therefore, in this particular one, do I have my, hold on, do I still have my, my tablet is that, yeah, I think she is still on. I'm bringing in, don't worry, when I'm talking. And here, I just wanted to write on it and then leave you with. We did that one. Next one. Oh, okay, now up. Yeah, that's what I want. Then I'm gonna zoom in. A proton accelerates from rest. V naught is 0 here. And then there is an electric field E. It's a proton, therefore we must know the charge Q, which is 1.602 times 10 raised to minus 19 coulomb, charge of a proton. And at some later time, it is V final is here, non-relativistic. Okay, find the acceleration. You simply say, what do you know? Force is equals to mass times acceleration, which is equals to E times Q. Then we know that side, the accelerations must be basically E times Q over M. I could go with that one. What else? How long does it take the proton to reach this speed? I'm going to use V final is equal to V naught plus 80. We know the final. We don't know this one. We get acceleration. T should be V final over A then. A get from there. It's easy. Let me see if the memo also follows the same thing that we're talking. So here. Yes. Guys, check there. I lost my tablet in between. The acceleration is QE over M as we agreed. Then this is the acceleration. V final is V naught plus 80. The final is given, Yeah, it's everything should be correct. And the remaining ones, it continues. There is a question. What maybe the final, how far it moved, it must be. Therefore, it's there. What is the kinetic energy? It's here. Guys, resolve it. And this is actually reminding you first semester. Rather, let's work here. Unless you guys insist, unless you say, how did you get? Is that all right? I know I'm tired also, you're tired also. So not going to be easy to continue. Yeah, Cesar, thank you, Cesar. Okay, a small, it says 2 gram plastic ball on this one. A small 2 glass plastic ball. I'm also opening my tablet, is going on and off. That tablet, yeah. I'm going to second page. Yeah, here. Yep. I'm coming. Yeah, that's what I want. The small 2 plastic ball is suspended by 2 centimeter long string in a uniform electric field as shown. If the ball is in equilibrium, good. When the string makes an angle of 50 degree and the vertical, what is the net charge on the ball? Oh, okay. Basically, this is easy. It's a plastic ball. The mass is given. The string is given. The angle is given. What is the charge? Okay, think of the electric field also. If the electric field is pushing that way, there is a repulsive, otherwise the gravity would bring back. I will see that, let me do this one. The mg must be down. That one is the force due to the electric must be that way. And then the tension must be up. Then if I think of this one, if we make like this, if that angle is 50, this angle is 90, what angle is that gonna be? Hey, don't sleep. 90 minus 17 is 75, guys, I believe. And decompose this one. T would be into 2 dimension along x and the y. The y component is going to be ty. The x component is going to be tx. Then you could see that the tx must be equals to fe if it is at equilibrium. Ty must be equals to mg, where T is the tension. You know everything. I believe I must have some memo for that one also. Yeah, it's here. Everything is there for you. And Newton's second law tells you, as you see the free body diagram, based on what we put, Fg is down, Qe is that way, the tension is up. If you decompose Fy is 0, T cos of that one is this much. Therefore, so tension is calculated. Along x-axis, the sum of f-axis along 0 is 0. Along x is 0, whereby Qe, that balance is that way, equal to T sine of that one, as we said. T is already solved. Q is this much. You should be happy with that one also. Is that okay, guys? Proceed. You know, habitation, as usual, when I go around the last minute, I run around. Sia, I say Sia, Sisa, okay? Dino.
Sorry, sir. Can you please explain it?
Good.
using your tablet,
Yes,
please.
okay. Yeah, there. You see what I say is, think of for this thing to be at equilibrium. Let me even repeat with a clean drawing. For this thing to be hanging in that position, what I mean is, the charge must be positive first of all, and then it should be pulling this way. This is the force due to the electric. Therefore, Fe must be Q times the electric field E. E is given. Q we're looking for. Mg always down. Then the tension is that way. It is pulling up. But you must decompose this one. This is going to be T along X is going to be Tx. Exactly this will have Ty. I'm saying for this thing to be stuck in that position at equilibrium, it says that y component must be equal to Tg. No, mg, sorry. What I say there is, let me write that one. For the sum of all forces along y, F along y to be 0, Ty, which is T sine of this angle, that means the cosine of that one, T sine of about this angle theta. T sine theta must be equal to mg. Do you agree that one? Dino said, and then Sisa also said yes. Solve for this thing is T must be mg over sine of that angle theta. On your memo, this is what you see. That angle is T sine of the other one. Is it true? Thumb and thumb. Oh, you see what the work is done. Actually, this angle is. Oh, okay. It's true though. It's all right. Instead of I'm calling it theta, you could say this angle is 30, the 50. That angle is also 50. You could decompose relative to that one, 50 degree. Basically, the y is up, the x is gonna be there. It doesn't matter. This is theta is 50 degree with no problem. T sine of 50 degree. Get T there. What we left is along x-axis. This one is not solved. Then we know T. T is mg over sine of 50, or take the formula which is given, times cosine, because this one is going to be T cos 15 degree, cosine of 50 degree, must be equal to E, the electric field, times Q. Then solve for Q. The memo, I'm going back to the memo. You see, once you get that one, then you get this one. Because I'm rushing, I think yes, yeah, I know where I made a mistake. It's not a mistake, but it's a rush. The angle. Take again. Take it away. Always cheap is expensive. If you rush, you make a mistake. Let's put the angles appropriately. Check. This angle is 50. If I put a straight line here, this angle is also 50. You must pick up that. Then when I decompose this tension relative to that one, the up is actually, let me write with this one, T, the y component is Ty is T cos of 15 degree. The x component is that one, which is this component. T along x is T sine 15 degree. The first one was right, 75 I is supposed to use. Therefore, this is T sine of 15 degree. Then we said, is it moving far? No, okay. T cos of 15 is equals to mg. T should be mg over cos of 15. For the x component, E times the electric field E times Q must be T sine of 15 degree. I'll put T is mg over cos of 15 degree times sine of 15 degree. Solve therefore, then basically Q must be 1 over E into mg. Cosine over sine is going to be tan of 50 degrees. This should be perfect. This is correct. Happy? I shouldn't rush. I'm tired. I'm going to leave you guys. And the remaining, it's good, Devin. These two equations, these two equations, question number 8 and the number 9, is a bit of tough. More, you see, that's why we said, if you are more inquisitive, you want to get more habitation, maybe you, because you always go beyond. In this particular one, the memo is still there. I'm not leaving you without the memo. The memo is still here. By the way, you could easily see what it is. Two identical beds, that one, M and M, are each has a mass M and a charge Q. When placed in a hemispherical ball, as you see this one, of a radius R with the frictionless non-conducting walls, the beds move and then at equilibrium and move, and at equilibrium they are a distance R apart. Determine the charge on each bed. Basically, this is an equilateral triangle. You see, R, R, R. Therefore, just solve on one of them. What is the net force on this one? The repulsive force, which is in a certain direction. Then again, the force due to this, the wall. I'm in a class, come in. Guys, the meeting, they say meeting is approaching. I'm gonna leave you. For that matter, there is where is the memo for this one? For the sphere. Here is the memo. Check the force is repulsive. That angle, you must know that if the triangles are, equal sided, the angle is 60, that angle you must know. Therefore, there is a force, the normal force that pushed by the hemisphere onto the beds. They repel each other also, that's the force of repulsive, equal and opposite. mg is down there. You could see the free body diagram. If you work it through, you pick up that this is the way forward. The question number 7, everywhere there. I'm going to leave you here. Before I forget, first of all, let me stop the recording. This is what happened last time. Recording, I stopped recording. Good, stopped. Guys, before I leave, I'm gonna say thank you, Bonganenzi. Yes, I'm clapping. Everybody's clapping. Thank you, guys. Let me stop.